Hello, in this video I want to explain to you how you can control the speed of a DC motor using feedback and interrupts. What I've got in front of you here is a set of Eblocks. I've got a PIC Micro microcontroller upstream board, a combo board with lights, displays and switches, and a motors board, stepper, DC and servo. And I've also got a logic analyzer connected in parallel with the motors board. We'll see that used in a bit. And if I show you how the program works first, I've got a little potentiometer here which I'm going to use just to control the speed of the DC motor. And you can see the display is showing a number between 0 and 255, which is our controlling speed from the analog potentiometer. It's showing the period, and it's also showing a frequency. So there's some floating point mathematics going on. Now you can just see here on the DC motor we've got a small bit of plastic attached to the rotor, and that plastic interrupts a little light sensor that's just down there, and every time the vane interrupts the light sensor a pulse is sent to the port, and that's the main feedback mechanism here. So let me show you how the program works. Let me just minimize that. So this is our program. On our panel I've got a display on port B, I've got a motor on port E, and I've got the potentiometer on port A, bit 1. I've also got a timer which we're going to be using, and the timer is great because it allows you to precisely time different events. In terms of the program, the main program, I'm initializing some stuff and I'm setting the DC motor forwards by 125 to start with. Then I'm having a little delay. I'm going to start the counter and I've got an interrupt. And the interrupt is, if we just look at the properties, on the rising edge of pin int 3, which I've set to be port E bit 7. So going back to the hardware, the little vane there is on port E bit 7, and you can see the LED there, and it goes on and off as the vane interrupts the light sensor. So every time there is an interrupt, we go and run this macro, feedback interrupt. And the first thing you'll notice is I'm putting a 1 out on port E bit 5 at the start of the routine and a 0 at the end, and that allows us to see on the logic analyzer when the feedback is taking place. So when there's an interrupt, I increase a counter, and there's 3 edges, if you like, or there's 3 vanes, so one whole count activates this routine. We get the timer of 1 whole revolution, we reset that timer and we reset the count, and then we put a flag where the data is ready, and that allows us to look in the main program. Let's just go down here. If the data is ready, then do some maths, and we're going to print that on the display. So that's the feedback interrupt. Going back to the main program, having set up the interrupt, there's an endless loop, as you can see here. Now we don't want to update the display every single loop. That would confuse the LCD display. So what we're doing actually is we're updating the display every 100 times we go around this loop. The little display there, so about, well, every 1 to 200 milliseconds, depending on how long the rest of the routine takes. So there's a counter display update count that manages this, and every 100 counts we get the value from the potentiometer and alter the speed accordingly, and then we run the routine update display. Update display, similarly to the feedback interrupt, has a pin, that's port E bit 3, that goes high and low at the start and end of the routine. And this routine just does some maths, updates the display accordingly, prints out the variables and so on. We don't need to go over that. So going back to the main routine, you can see that the endless loop, update the display where it needs to, Also, it's managing the feedback from the interrupt using the data ready flag. Okay, let's just look at this from a slightly different perspective. Let's look at the logic analyzer output. So here's the logic analyzer, and you can see that the PWM is varying according to the speed. I better stop that and explain the signals to you. Bit 0 is not used. The PWM from the motor is displayed there. The direction is always in the same way, forwards, and you can see here update display, so you can see how often the display is being updated there by looking at port E bit 3. Here's the feedback interrupt. You can see how often that's being activated. There's probably a little aliasing, or it seems to be missing one occasionally, which is slightly odd. And here's the feedback pin. So the logic analyzer is a great tool for understanding your program, and just setting bits to go high and low in your program is a great debug facility that logic analyzers provide for you. So I think you'll need to get hold of that program and study it a bit, but hopefully you'll be able to make sense of how it all works. Thanks for watching.